Okay, this is our last INB lesson for chapter. So when we're done with this one, we'll be doing some homework. This one will probably be 2 days worth of homework, and then we'll be moving on to reviewing for our test. That will be the following next Monday, Tuesday. As of now, that can change, I guess, if we feel like we need more time. So this lesson is simplifying rational expressions. We're going to just simplify them, and we're going to also add, subtract, multiply, and divide. I didn't have divide up here. So multiplying and dividing are easy. Adding and subtracting are the more difficult problems. Okay, so the first thing that I'm going to do is factor. Factor the top numerator, and I'm going to factor the denominator. This is a nice one. It's an x squared, so I can just say factors of 4 that add to get -6, -4, -2. Always get used to doing the points of discontinuity or the numbers that are going to cause the denominator to be 0. So we focus on this one on the last INB. So x can't equal 4 because of the x minus 4, and x can't equal 2. Those would both cause those factors to become 0, and you can't have 0 in the denominator. So x cannot equal 4 or 2. And then I'm going to reduce any similar factors out. I have an x minus 2 and an x minus 2. That becomes 1. And this reduces to x plus 2 over x minus 4. Notice, even though it reduces out, that this is still an excluded value, even though the x minus 2 reduces out. It might be smart for practice to go ahead and do your domain, especially if that's kind of a tricky issue for you. It's pretty easy, just takes practice. And there's my domain. So you might want to practice that. Okay, another one. Difference of squares. Recognizing difference of squares. That's the hardest part about factoring, is recognizing each case. This one's 4 terms, so I know I'm going to group. And I'm going to pull out an x squared plus 1. I'm going to pull out a -9. Remember to always pull out that sign. And I get an x plus 1. If you're able to group, then you're going to have those repeated factors. So I have an x plus 1, and those pull out, and I'm left with an x squared minus 9. And when I write these underneath here, I'm going to write x plus 1, but then I have another difference of squares, x 3 times x plus 3. What are my excluded values? X can't equal -1 because of the x plus 1. X can't equal 3 and -3. And all these reduce out. Just a common mistake is saying that the numerator would be 0. It's not 0. Remember, all these are reducing out to 1, because anything divided by itself is 1. So x minus 3 divided by x minus 3 is 1. So this is 1 over. If I wanted to do the domain of this one, starting with your smallest value, I'm going to go -infinity to -3, -3 to -1, union with -1 to 3, union with 3 to infinity. Practice those a couple times and you'll have interval notation down pat. Number 3 was listening to putting some harder problems on here. So this is one, and it's not that hard. It's just a trick. If you notice here, I'm going to factor my difference of squares in the denominator. And then I notice the numerator is pretty close to being another, what? I have a -x and a +9. So if I put this in standard form, I get -x plus 9. Those cannot reduce with the denominator. None of those are a -x and a +9. So what I can do is I can factor out a negative number. And so I'm going to factor out a -1, and that just is going to change the signs of both binomials so that x becomes positive and the 9 now becomes negative. And that little trick enables me to reduce these out. leaving me with a -1 on top and then x plus 9 on the denominator. Remember, my x can't be 9 or -9, and my domain would be from -infinity to -9, -9, and from 9. Okay, next one. Uh, difference of cubes. And so I know if I write this as a cube, this is 4 cubed and this is x cubed. There's my bases, x and a 4. Then I remember square, multiply square, square them, multiply them, square them, same, opposite, always positive. Remember, this trinomial is going to have complex or imaginary solutions. Put it in the quadratic formula, you'll get a negative number square root. That's always going to be the case, so don't go to that trinomial and try to factor it because it's not going to be able to be factored. The denominator, a nice, easy numbers that multiply to get 16 that add to get -8. That's because it's an x squared. It doesn't have a 2 or a 4 in front of the x squared. So I can just put up my x's and say, what is that combination? Looks like -4 and 4. And one of those -4s cancel out. What can x equal? 4 and -4. And -4, 4, 4, 4. Okay. So that was a bunch of just simplifying. Now the next thing that I'm going to do is we're going to kind of go into the other operations. So we're going to focus on a multiplying and a dividing, and then we'll focus on the harder ones, which are adding and subtracting. So we have 4 of those left. Multiplying and dividing are pretty simple. They're the same thing. You're just going to be doing it with 2 numerators and 2 denominators. So I'm going to factor everything. Common factor. Might even want to write that x squared as x times x. Notice how this one's written backwards. It's 3 minus x. So I'm going to pull out a negative because I know that's what's going to happen. Oops. My 3 negative and my x positive. And then my 5 on the denominator. Now, because multiplication, numerator times numerator, denominator times denominator, this is really one big fraction. And that's how we want to think of it. So this x minus 3 cancels or reduces to 1 with this one. This x reduces here with this x. This 5 will never reduce with this x plus 5. This x plus 5 is its own entity. You cannot take half of that and cancel it with or reduce it with that 5. Don't ever do that. It's a common thing to want to do. So I'm left in my numerator with, well, that x canceled. It kind of didn't show that it did. So I'm left with x plus 5. And in the denominator, I'm going to take that negative and bring it out in front. All right, x. I guess it's just a 5x. Erase that. 5x. There we go. And if we go and look at our denominator, x can't equal 0, and it couldn't have equaled, what was that? A positive 3. So negative infinity to 0, mu of 0 to 3, mu of 3. So multiplication, not much more different than what we've just been doing. Division, same thing, except remember leave, change, keep. So I'm going to do all that at once. So I like to just go ahead, if you're going to do these, might as well just factor the first one out. Remember that one stays the same. You leave it alone. So this one looks like a difference of squares, x minus 7 times x minus 7. And then I'm going to reciprocate, right? Leave, change, flip. So the x plus 7 numerator, pull out a 3, 7 denominator. And now remember, we're one big fraction. All those 3 terms on the top are on the top, one fraction, and the denominator. So I'm free to cancel or reduce any numerator with any denominator. We go across fractions. And what am I left with? It's like a third. So 1 on the top, 3 on the bottom. What could I not equal? Here, I couldn't equal -7 and 7. This one was -7, and then I reciprocated it. I had a +7 when I reciprocated it. So it's just these two. But on division, you have to exclude all of these values in the beginning, and then when you reciprocate it, you also have to exclude the reciprocated denominator too. So it's a little bit tricky. You have to check in 3 places: 1, 2, and then this third one. Okay. Adding and subtracting is probably the harder ones because we're going to be doing combining fractions with variables, and that can be confusing for some students. Remember, if you have just a whole number or an integer, it always has the denominator of 1, which makes it nice because I can make 1 anything that I want. So the common denominator is x minus 1. And remember, when you add or subtract, you keep the common denominator, x minus 1, and then the numerator. Careful on the subtraction. The subtraction sign goes up in the numerator and is going to get distributed through the numerator always. Okay, always. So that subtraction sign always is going to come up to the numerator after the subtraction sign when you combine these two things together. So I get a -5x plus 5 after distributing this -5 through. I'm going to combine and get 8. And x can equal 1. I'm going to not do the domain. Y'all can do the domain, but I'm just going to save some time. Okay. Next one, you definitely would want to factor these if possible. These both can't factor, but sometimes you like if this was a 2 here, I could pull out a 2 and get an x plus 1, and that just is a little more user friendly when getting a common denominator. A lot of these, though, when all else fails, you don't see a common denominator. It's just going to be those two multiplied by each other. So I'm going to multiply. The common denominator is going to end up being 2x plus 1 times x on both of these. So this 4 is going to get multiplied by x plus 2, and this x is going to get multiplied by the 2x plus 1, whichever one it was missing. So this one had the 2x plus 1, so I needed to multiply by the x plus 2. This one had the x plus 2, the second one, so I had to multiply the top and bottom by the 2x plus 1. Okay, when you do the denominator, just leave it in factored form. There's no reason to multiply that out. Numerators, however, you're going to multiply out because you're more than likely going to have like terms. And then I'm going to combine that work over here. 2x squared plus 5x plus 8. I don't think if I could factor that, I would try factors of 16 that I had to get 5. That's not going to, there's not anything that's going to work there. It's not that. I'm just going to leave it like most of the time you just leave it, find the common denominator. So what could x equal? X can equal a half -2. Okay. All right. So these get more complicated. More factors you have. So x minus, what is this? X minus 2, x plus 1. And then notice this subtraction sign that always messes students up. So when I'm going to multiply this through after I forget the common denominator, it's going to be a negative x if it gets distributed. X minus, or x plus 4, x minus 2. Got lucky because at least they share one common factor of x minus 2. Anyways, so They both have an x minus 2, so this one's going to need an x plus 4, and this one's going to need the x plus 1. Really, it doesn't matter. I mean, I'm just going to go back and check. Everybody's got an x plus 1, everybody's got an x minus 2, everybody's got an x plus 4 in the denominator, so everything's in common. Now I'm ready to distribute through. Get 2x plus 8 on this fraction. Remember, minus goes right up here. I get negative x squared minus x all over this. Don't multiply them all the way. And I might tidy up this, write it in standard form. So negative x squared plus x. What's that? Let me see if I can factor this one out. So if I take the negative out in front, we'll get 1 minus 8. Factors of 8 that subtract to get me 1. This, I'm good to go here. So what can x equal? Negative 4, 2, 1. A couple more. This one, x minus 1, x plus 1. Okay, so that's going to be the common denominator, right? So this one's already got it. It's not going to change. So let me bring it down. This one needs the x plus 1. This one needs the x minus 1. So even though it has 3 terms, it's kind of an easy one. I'm going to go ahead and distribute. I get 2x plus 2 on this one. And no minuses, so we're good to just go 2x minus 2 minus 1. I'm going to combine my like terms and write it under all of this. That's what we got. We got 4x. 2 is reduced to 0 plus 1. And x equal. Okay, next one. These are complex fractions. We kind of looked at these already. These are fractions within a fraction. So notice, I know I have this when I have fraction bars, and I have a big old fraction. So see 3 fraction bars up here, right? Everything was just 1 fraction bar. So I had 2 divided by 1 numerator, 1 denominator. Here's where I run into the problem. I see a numerator up here, I see a numerator here, and a denominator here, and then I can look at this as one big denominator. That's when you know you have a complex fraction. So complex fraction, the whole goal, 1 fraction in the top divided by 1 fraction. 1 fraction. Goal is 1 fraction. This is 2 fractions. This one we can consider as 1 fraction because I can write x minus 4, which is its own factor, over 1. So in this denominator, I'm going to have to get a common denominator. And usually these complex fractions are pretty nice, is their denominators are pretty friendly. So it's pretty easy to see that this is just going to be 4x. I need to multiply this one by 4, this one by x. So I end up with x squared. And what is that? Minus 16. Notice that's a difference of squares right away, divided by 4x. Okay, the next step is leave change split, leave the top fraction. Notice I changed it into a fraction, even though it wasn't originally, just it's more visually pleasing to see that as x minus 4 divided by 1 and leaving it that, especially when I'm going to flip this. So then I have, and notice I'm just going to go ahead and factor that, reduce out my x minus 4s, right 4x over x plus 4. So what can't x equal? Well, x can't equal 0 because the down here is fraction, right? And then what else can it equal? So I got that done. Here's the 0, and then I flipped it so it can equal negative 4 and 4. There. I think those are all the spots that I had denominators where there's a potential for zeros. Okay, next one. So y'all asked for a hard one, so number 12, I left us with a hard one. Okay, so lots of fraction bars, 1, and then a big one. All you need is 2 to be a complex fraction. So there we go. So here's my denominator of that 2 fractions up here. This is 1. So I know what am I going to need to do here? I need to go get this to be common denominator. I'm not really worried about rationalizing at that point. At this point, let's not make it any harder right now. I can always rationalize at the end. Right now, I'm just going to get a common denominator, and it's going to be this denominator. And if you notice, this denominator, because this one's 1, I can multiply anything by 1, get it. But this denominator is the same as the numerator, and this is square root. So when I multiply this by t squared plus 1, and I multiply this top by t squared plus 1, I get that property of square root times the exact same square root. It's just a common piece underneath the radical because it pairs it up. So I have a t squared. Okay, and I have this is the part where it takes where you don't have discipline, easy to make a mistake. This is a subtraction parentheses squared plus 1. Okay, and then my denominator was that square root all divided by t squared. Okay, so I'm going to distribute this negative through, and what do I get? My t squareds are going to cancel right out. I'm just going to do that right up here. Hope you don't mind. And that's going to be just a negative 1, right? So all I'm left with is this negative 1 divided by that common denominator of radical. So I wanted to save some room. So I'm going to leave negative 1 square root of t squared plus 1. Change it to multiplication. And I'm going to flip the bottom. Okay? And I get negative 1 over t squared times t squared plus 1. Now this is where I need to rationalize. So here I go. Just going to don't this t squared out in front. It's totally fine. Not under a radical, so I'm just going to leave it there. So I get this like t squared times, well, t squared. And what am I left with? A negative t squared. And I'm okay with just leaving it like that. No reason to multiply that out. Of course you can. But remember, a lot of times at the very end, you want to talk about like what your domain and all of that. Like so, x can. There's nothing that's going to make that a 0. Nothing is going to make that a 0, but a 0. The 2 can equal 0. And well, this denominator down here, right? The only thing about the denominator here is it can't be negative and it can't be 0. Well, I can't square anything and get it to be negative. And the only way to get a 0 is if this t squared was negative 1, which will never happen. So looks like the only thing that we have to worry about is t can equal 0. Okay, so we'll be practicing on this a couple days. It's kind of a long one, but our last one before we move on to chapter 1. Thanks. See ya.